So hello everyone, welcome to another video in fluid mechanics under chapter 2, the principle of hydrostatic. So let's start. Fresh water and seawater flowing in a parallel horizontal pipelines are connected to each other by a double U-tube manometer as shown. Determine the pressure difference between the two pipelines in kilopascal. Take the density of seawater at that location to be 1035 kg per cubic meter. Neglect the air column. So the given in this problem are the density of seawater, which is 1035 kg per cubic meter. Also, as we all know that the density of fresh water is equals to 1000 kg per cubic meter and the density of mercury is 13,600 kg per cubic meter. So let's start solving. But let's consider that the downward is positive and upward is negative. So let's start from fresh water. So the pressure of fresh water plus the density of fresh water times the acceleration due to gravity times to its height. So it is positive since it is downward, minus to the density of mercury times the acceleration due to gravity times to its height. So again, it is negative since it is upward, plus the density of seawater times the acceleration due to gravity times to its height is equals to the pressure of seawater. So we neglect the air column since it is stated in the problem. So transposing the equation to get pressure of fresh water minus pressure of seawater is equals to the negative density of fresh water times the acceleration due to gravity times height plus density of mercury times acceleration due to gravity times height minus the density of seawater times acceleration due to gravity times height. So now let's plug in the given. So 1000 kg per cubic meter times 9.81 meter per s squared times 0.6 meter. So let's convert the height into meter, plus 13,600 kg per cubic meter times 9.81 meter per s squared times 0.1 meter. So in this part, we just neglect it since it is in the same height and in the same liquid, so we can just cancel it out. So let's proceed to seawater minus 1035 kg per cubic meter times 9.81 meter per s squared times 0.4. So calculating, pressure of fresh water minus pressure of seawater is equals to negative 5,886 Newton per square meter. So it becomes Newton per square meter since kilogram meter per s squared is equals to Newton, and we can cancel the meter here, so that's why it becomes Newton per square meter plus 13,341.6 Newton per square meter minus 4,061.34 Newton per square meter. So calculating, pressure of fresh water minus pressure of seawater is equals to 3,394.26 Pascal. So it becomes Pascal since 1 Newton per square meter is also equals to 1 Pascal. So now let's convert it into kilopascal. So we just need to divide it into 1000 in order for us to cancel the unit Pascal. So the final answer, but between the pressure difference between the two pipes are 3.39 kilopascal. That's all. Thank you.